In this session, I'll be live coding an example application using Qtable View and trying to use Designer and Creator effectively to make this process as simple as it can be. My name is Shawn Rutledge, and you have my contact information there on the screen. I've been a Qt application developer since about 2004, and then I joined Nokia in 2011, and I've been mostly focused on trying to get touch working better in Qt Quick. That led me to writing the Qt Quick input handlers. Tried to make Wacom tablets work better in Qt. I've worked on other platform issues and a couple of other things. I'll introduce in this session QPS, which is an existing widget application that I'm basically trying to live code or recreate. And we'll go through the relevant API and the collaboration between the view and the model, and then we'll jump into the code. So QPS is an old application that was started in about 97 as a desktop application. It looks like this to display the processes that are running on your system. So it's kind of similar to top. If you go to a terminal and run top, it looks like that. QPS is basically a graphical version of that. And I was hoping to be able to find some example QAbstract table model in there that I would be able to reuse for my presentation. It turned out to be not quite that simple, but I was able to reuse some code from that. QPS nowadays is part of the LXQt desktop, and here's my fork on GitHub that I used for the presentation, so you can see the code afterwards. Okay, so let's review the API a little bit. In widget applications, when you want to display a table, you use Qtable View, and your model typically is going to be a QAbstract table model subclass. If the table view is trying to render this particular cell right here that I've highlighted in green, well, how is it going to get that string? Usually it will call the data function in your model, and it's going to pass in a QModel index in which the column is 5 and the row is 9. And then the display role will be the role that it usually wants to get, because it wants to get the text for display purposes. In our case, I'll be showing you how I use QSort filter proxy model. I use a subclass of that to do sorting, filtering, and rearranging the data a bit. So if you have a proxy model, then it's going to call the data function on the proxy model, and then that does some mapping of the columns and rows to a different coordinate system, and then it calls the data function on the original model. So let's get into the code. I'm starting from scratch here, and I want to create this application. So let's start by creating a new widget application. So we can choose application, widget application. And I'm going to call it Qtable View. And I'm only interested in building for the release version of 5.12 at this point. QMain window is fine. I don't need to add it to Git. And Creator creates a basic template for a main window application. So we have our main window form here, which if I double click it will open up in Designer. And there's an empty form. It can have a menu bar, a toolbar, and so forth. So I need to start by adding a table view. Notice there's also table widget. The reason I don't want to use table widget is that I know that I have some model code that I'm going to reuse. Table widget has its own model built in, so that's supposed to be a quick and dirty solution. If you want to programmatically add some data directly to the widget, then you can do that. But we don't want to write that kind of imperative code because we've already got a model. And so the table view is just the view part. So if you want to keep proper model view separation, then you use that. So there's table view. And of course I need to resize it to fit the window, but the thing is, when I resize the window, we need to use the layout manager in order to automatically make it resize along with the window. Now of course start to think about what sort of layout manager, and you notice that there are these layouts here. But if you drag one of those in there, you still have the same problem, that this layout needs to be set to fill the window. So actually what you want to do instead is just select the window and hit one of these buttons up here. either lay out vertically or lay out horizontally. In my case, I'm going to lay it out vertically, but it doesn't really matter because there's only one widget that I want to fill the window. Okay, so if I save that, next thing I need to do is start pulling in some code for the model that I already have. There's the source files. There's the headers. Right, so main window, the UI will be created, and then we're going to populate our table view. Okay, I need to have a model, so let's go ahead and create one of those. So here's our application. It's simply displaying information about the processes running on my system, not in a very organized or nice way. Yeah, we have data in a table view. Okay, let's look into the details of how this model works a little bit. Whenever you subclass QAbstractTableModel, there are at least 3 functions you need to override. There's the row count, column count, which specify those numbers, and then the data function is the interesting one that takes the role is going to be display role by default, and then we need to return a string. So let's look at the code that I reused from QPS. Procinfo, it's a storage class for the information about a single process, and cat is the data type of an individual field in there. Well, first we find the process corresponding to an individual process ID, then we find the value that we're interested according to which column we're in, and that's a tree of classes where we have a base class and then it has some virtual functions. One of the functions is string, and that's the one we're interested in returning. Get the string for display purposes, and then they have subclasses for, if it's an integer, that's one type, and it knows how to convert an integer to a string, and then if it's a amount of memory being used, it knows how to convert that to a string, and so forth. There's the string itself, and the user, and the group, and process state, and a whole bunch of these subclasses. What was I going to do next? I think I wanted to have some sorting, and I want those columns to be a better size by default. So to enable sorting on a table is quite simple. You just select the table view, and in the properties you set sorting enabled. The next thing I wanted to do is to add a quit action. I can create a new menu, the file menu, with a quit action, and as soon as I do that, I have my action down here. I need to give it a shortcut, so I right click and Control Q, and I can also put this action on my toolbar just by dragging it there. Next thing we have to do is create the slot to handle this. So I right click on the action and I hit go to slot, and when this action is triggered, this function will be called. So Creator created the implementation here for me, and all I have to do is fill it in. So I'm going to call QAppQuit when this action is triggered. That's a special bit of magic that if your main window is subclassing QMainWindow and then you're following the naming convention like this, on action whatever underscore triggered, then it's going to automatically wire up the signal slot connection. So when the emits the triggered signal, it will call this slot, and then you'll be able to do whatever you want in the code there. So let's try this again. And this is already starting to look quite a bit better. The fields are in the same order as they are on top, and I can sort them so I can find which process is taking the most memory on my system right now. and I can quit by clicking that or hitting Control Q. So what's next? I wanted to have some control over the rate at which the process information will update, and I want to start doing some filtering. So if we go to our UI, the thing that I want to do is have a spin box to control the rate at which it updates. So I think I'll try to put one of those on the toolbar. Oh no, it doesn't let me drag the spin box to the toolbar. The problem is the toolbar has a programmatic API to add widgets to the toolbar, but you can't do it in Designer. So I'm going to show you a little trick that you can use to work around that. I'm going to make a layout in here. Now first I have to break the layout of the main window itself, and then I can put this other layout in here. I'm going to call this toolbar stuff, and I'm going to put things in there that actually should be in the toolbar, and then I'm going to show you how to move those into the toolbar. So I need a spin box, and I need a label or two to tell you what the spin box is actually for, to tell the user what it's for. So this is going to be the spin box that controls how often it updates. So I'll say update every this many seconds. So let's lay this out vertically. And now I'm going to show you signal slot editing. We've been editing widgets all along on this form, but now what I need to do is when the spin box changes, I need to do something. So I'm able to now select the spin box and draw lines, and when the editing is finished, we'll be able to do something, or when the value is changed, we'll be able to do something. That's a better idea. Okay, what do I need to do? I know that it's going to give me an int, and I need to connect to something. So I think I need to make a property which will store the rate at which the timer should update the process information. So I'm going to make a Q property, and Creator's going to help me write that. So the type is what? Int. The name is what? How about update interval? And notice as I'm typing, it creates the setter and the getter names. When I go to the end and hit enter, it will actually capitalize it correctly. And then I can right click and I can refactor generate missing property members, and it actually wrote the getter and the setter and the storage for me. So now I'll just make this look a little bit more compact, and I usually move the setter to the CPP because there's going to be more code in there. And next thing I need to do is actually have a timer, so I'll show you the typical way that a Q object can have a timer for some purpose. So when the update interval changes, you need to start a timer. And how often? The update interval tells me in seconds, but I need to specify in milliseconds. Okay, but we don't want to keep doing this repeatedly. If there are multiple timers running, that wouldn't be a good thing. So if we already have one, we can stop it. And then we can start a new one. That should be good. And then the next thing we need to do is actually handle the timer event. So every Q object can have multiple timers actually, and then the timer event tells you which timer it is that's firing. Then you can do something when the timer fires. So in my case, I want to update my process model every time the timer fires. Now I didn't declare this yet, so let's just refactor, add a protected declaration. It answered to the protected section of my class. Okay, now we can go back to wiring this up. So when the user changes the update interval, the value will change, and I need to call a slot. And the slot was set update interval taking an int. Then I select that, and now I've made a signal slot connection without writing the code. It's just in the UI file. Okay, so if we go ahead and run this, it should be that every time I change this, now it's updating once per second. But I still need to move the stuff into the toolbar. So, toolbar stuff. While it still has something, we can add each widget that is in toolbar stuff. To the toolbar itself, and then when we're done with that, we can actually delete toolbar stuff. Okay, so that should work. The next thing I wanted to do is to add the search field. So let's go back to widget editing, and then I'll have the single line text editing widget, which is a line edit. I'll stick one of those over there. And I don't want this to look too bunched up, so I'll put a horizontal spacer, this little spring in there to give me some space. And I'll need to wire that up as well. So I think we'll have to add another property, which will be the filter field. This one's going to be a string. And again, I'll have creator generate the missing stuff and move this to the CPP. And when that one changes, I'm simply going to set the filter as a regular expression. And notice when I connect directly to the main form itself, there's this ground symbol. It's almost like it's an electrical symbol that you're connecting to the ground plane, which is interesting, but yeah, that's what it looks like. And I want to have type ahead search. So I'm going to say when the text is edited, meaning it's edited by the user, that emits a string, and that's when we want to update the search field. And now I can choose that. So now I should have type ahead search to be able to filter the processes by name. And I still have sorting. I still have the ability to control the rate at which it updates. Everything has been transplanted into the toolbar now. So notice I can also use the file menu to quit. Okay, what's next? I wanted to show you how to make custom delegates, because so far all of those cells in the table look alike. First, let's read the docs. So if I start looking at the docs for table view, eventually it explains down here about how delegates are used. The items shown in a table view are rendered and edited using standard delegates. And you can also insert widgets into a table. For particular indexes, you can call set index widget, but we don't really want to do that because that would involve iterating over all of the rows in the table and then creating individual instances of widgets and sticking them into particular cells, right? So I think what I want to do instead is just have an entire column in the table use a different delegate than usual. And then if you start reading about the item delegates, then it explains that item delegates provide display and editing facilities for data items. And the thing is, the Q-styled item delegate is the one that is nowadays used. And so you should use that one when you're to subclass to create a new type of delegate. The reason for that is that the Q-styled item delegate can use the Q-style to provide platform-specific rendering, so it'll actually look native. Okay, so I'm going to make a new subclass of that. So C++ class, I'm going to call it bar graph delegate, and its base class is Q-styled item delegate. Yes, it's a Q object. And there's my subclass. And so in order to make this render something, I need to implement the paint function. Can right-click on the refactor menu, add a definition to create the function, and then we need to start creating this function. And I'm going to take a shortcut because I've already done this once, and just go to the next step where I have already implemented this function. So yeah, the paint takes a painter because when the QTable view is rendering, it already has one painter that it uses for everything. And the QStyle option view item tells you the area that's going to be painted. And then the model index will tell us which column and row we're rendering. In my model, I have this extra user role, which is a type role, and I can actually ask the model what type is the data for a particular cell. If the role is type, then I said if it's CPU or memory field, then that's a percentage. And then we have other types for other purposes. So over here I said if the type is a percentage, then this is the case where we want to use the bar graph. So the number is another custom role where I can ask my data function to give me the data as a number instead of a string. And I did that by adding another virtual to this QPS category type that returns it as returns data in a sortable format, because I needed that for numeric sorting anyway. So I have it return a variant which, if it can be represented as a number, then it will be. And then in my delegate, I asked to convert that number into a double, so that gives me the percentage from 0 to 100. And then I use that here to set the progress on the progress bar. So we want to draw a progress bar. We ask the Q application's platform style to draw a control, which is a progress bar. There's a lot of these control elements that you can choose from to ask the style to draw something that looks correct on your current platform. And then you have to pass in this progress bar option where we specify the information necessary to draw the progress bar. So the main thing it needs to know is how far across the progress actually is, and the text that's going to go on top. And then if it's not a percentage, then we'll just fall back to using the Q-styled item delegate paint, which was already doing a pretty good job drawing text on its own. Okay, the next thing I needed to do is to actually install this. And I did a similar thing here. I said, let's go through the columns, and if the data for this particular column is supposed to be a percentage, then we're going to use this item delegate. So whereas otherwise it would use the default item delegate. So that's actually a bit redundant because I'm checking the type in two different places. It would actually be enough to just do this part and then then the bar graph delegate wouldn't have to care about the cases where it's not a percentage because it only knows how to draw percentages. But whatever, I shoot it both ways, so you can make up your mind which is better. If you want to make one delegate that can render any type of data, you can do that by checking the type in your delegate itself, or you can just replace the delegate on certain columns as necessary. You can have different delegate classes for each column if you like. So the result now is that I have the CPU and the memory showing a bar graph instead of just the plain text. And right now you can see this screen recorder that I'm using to record the presentation is taking most of the CPU, which makes some sense, taking quite a bit of memory as well. Okay, so the bar graph looks a little bit nicer, and this is an example of how you do custom delegates. What was I going to do next? Show you how to create context menus. So in the UI, the policy is a default context menu. We need to change this to custom context menu so that we can generate a custom one. And next thing is to actually generate the menu. So there's a slot for that. So I right-click, go to slot, and when a custom context menu is being requested at a particular point in this widget, then this slot will be called. Okay, so I was given a point, and that's in the context of the table view. So a couple things I need to do here. One is to figure out which cell that is in the table, and the other is to actually pop up a context menu in the right place. So let's start by creating a context menu. So I simply need a Q menu, and I have to import the type, and then we can start by populating that. Okay, but I'm going to add the action here. I need to have a kill process action, because what I want to do is to be able to right-click on any process in this table and ask the system to kill that, and it doesn't need a shortcut. So I now have my action kill process. So we now have our action to kill the process, and we can add it to the context menu. The reason it said there's no member is that I hadn't done a build yet, so it hadn't generated the code. So notice all this here's all the code that the UI compiler generated for me. Every time I edit my UI file, when I do a build, this file will be recreated. So here's everything I've created in there, the actions, the widgets, and so forth, and then there's the setup UI function that does all of this boilerplate code that you might have otherwise had to do yourself. But see, it's much easier to use Designer to create your forms, and then use the UI compiler to generate all of this code. And this happens automatically because we specified forms in our PRO file. We specified which UI file we're going to use, and so the make file that QMake generated will call the UI compiler to generate this code for us. So that's why it's as simple as that, but you have to do a build in order to make sure that those variables exist. Okay, so we have a context menu, and I want to show it somewhere. To show a context menu, you can call exec, and you have to specify again the position where you're going to show it. So I can ask the table view to map the coordinate that I was given to global coordinates, and that means on the screen, because a context menu is a separate window, so you can actually show it anywhere on the screen. And then that, when I call exec, is going to return an action. So if the action that it returned is the kill process action, then we're interested in reacting. So the next thing I need to do is find where I am in the table, meaning which process I want to kill. I can get the index by calling table view index at position. This takes a pixel position inside the table, so that's good. And next, I know that I want to get the PID. I know I need to call the data function, and I'm going to have to specify an index. But we can create a new index and a particular row and column. So what's the row? The row is this index of the row that we clicked on. The column is always going to be 0 because I know that the PID is in column 0. So there's my index, and then what do I want to get? I want the data as an integer. So I have this special role for that, number, and then I can convert that to an int, but I want to ask whether I'm succeeding in actually getting it as an integer. And this toInt function can take a bool and then tell you whether it succeeded or not. Right. What I get out of there is an integer. So if I succeeded, then it would be okay to kill that process. Okay, so let's see if this works. So I right-click and I say kill process, and that should be PID 4. And look, it worked. It found PID 4 by getting that out of the data model. Likewise, if I do this, then it's process 11. So there you go. And the next thing I wanted to show you is a trick to have scrolling in the table view, but I'm going to just show you the code for that rather than writing it from scratch. So by default, when I select with the mouse, I select cells in the table, and then I can scroll this way by dragging that, or I can use the wheel on my mouse. So now I'll show you how I can make this application work a little bit better on a touchscreen. I have changed the code in such a way that I can flick the table with my finger, and I can still select cells with the mouse, and I can also tap with my finger in this filter field and start typing as I could before. So I'll show you how you can do that. You can call QScroller grab gesture. This is a static function that registers a scroll gesture recognizer, grabs it for the target widget. So grab gesture, table view, touch gesture, and so the problem was that as soon as I did this grab gesture with touch gesture, that then the touch would do two different things. It would flick the table, and at the same time it would try to select cells, because in widget applications, touch events usually are used to synthesize mouse events. So since we've now made it so that the QScroller is going to react to touch, we need to disable the mouse synthesis. So the way you do that is by setting the attribute synthesize mouse for unhandled touch events to false. And so then I had to selectively re-enable it, handling the touch events in certain widgets. And that was kind of useful for the toolbar stuff. So at the same time that I'm transplanting the things from toolbar stuff into the actual toolbar, I also call the set attribute accept touch events on each widget in there. And so the result is that I can actually click some of those things in the toolbar using touch. So that's the end of this session about widgets best practices, and thanks for watching. There's my contact information again. The presentation, meaning these slides, which aren't very interesting, is on this GitHub repo, and the code that I'm showing you is in this one. It's a fork of QPS. So thanks for watching. See you next time.